nanohub.org.
Online simulation and more for nanotechnology.
So good morning, brave souls. So I'd like to begin by thanking the organizers for inviting me and to apologize for not being here yesterday. I had some teaching commitments that had to come first, but I'm happy to be here. I'd like to begin by acknowledging the contributions of my co-author to much of my recent work on measuring resilience, and that's Noah Dormady, who's a former PhD student of mine at USC, and he's about to get tenure at Ohio State, so I'm very proud of him. So I'd like to begin by sort of explaining what might be a mystery to some of you, why I've juxtaposed mitigation and resilience, and start with the standard definition. This is from National Research Council report about, well, now it's 7 years ago, time flies, but it's pretty similar to the Executive Office of the President's definition and the DHS definition. You can read it yourself, but it includes several things we can do to reduce risks: prepare and plan for, absorb, recover from, or more successfully adapt to actual or potential adverse events. So mitigation, to me, covers those first two aspects, the prepare and plan, and mainly absorb or resist, often referred to as robustness. And it's, you know, the most well-known of the actions one takes to reduce risk. I've been involved in some major studies known as the Mitigation Saves studies, and these have done pioneering work on measuring and evaluating the cost effectiveness of mitigation for buildings, and we all know many other studies that have done such work for infrastructure. But my presentation today focuses on the other aspects and highlights the importance of reducing business interruption and not just property damage. And so essentially I'm summarizing progress on what I refer to as resilience saves as opposed to mitigation saves. So 15 years ago, I had the honor of being the lead researcher on a congressionally mandated study called Mitigation Saves. And in this, we analyzed 10 years of FEMA Hazard Mitigation Grant Program outlays between 1993 and mid-2003. And these mainly applied to public sector buildings. So there were $3.5 billion worth of these grants over that period that resulted in $14 billion in discounted present value savings, giving us a benefit cost ratio of 4-to-1. So some of you may know this study as the 4-to-1 study. This 4-to-1 benefit cost ratio is essentially equal to a 14% rate of return on a 50-year annuity, even without including many co-benefits that are now becoming more popular to undertake. Right off the bat, the study led to an increase in appropriations, congressional appropriations for mitigation of $100 million, and is thought to have spurred even more mitigation support from the federal government. And it's been widely cited in congressional hearings ever since. Now, one of the limitations of that study was that it focused almost entirely on public sector buildings, fire stations, city halls, etc. And 90% of the buildings and infrastructure in the U.S. are private. And so we've done some thinking about that, and there's no indication that the benefit cost ratio for these private sector structures would be any less than 4-to-1, but what was needed was a good solid study like the previous one. And, you know, there's been some documentation of this potential, dozens of studies. Well, there were several projects in the original report. And the MMC, I forgot to say, the study we did in Mitigation Saves 1 was an independent study, independent from FEMA, and it was done under the auspices of the National Institute of Building Sciences, Multi-Hazard Mitigation Council. So that's what MMC stands for. So we can also draw many analogies between public buildings and private sector buildings for many hazard threats. And there are many case studies done by individual companies showing that, mitigation in the private sector pays off as well. But what was finally decided was, well, we needed a good, thorough, comprehensive study on the private sector side, and hence we are in the midst of the Mitigation Saves 2 studies. These are sponsored by FEMA, Economic Development Administration, HUD, and various building groups like IBHS. Keith Porter, who is my co-lead on the original study, is the lead on this. Keith's in civil engineering at Colorado University. So some of the preliminary findings, the first report came out late 2017, was this is being done in modules, and there are about 8 modules, and the first 3 came out in 2017. The others are about to be, 3 more are about to be released coming up. And the findings were that if we looked at not just the 10 years of federal grants and looked at more recent grants, the benefit cost ratio was in fact 6-to-1. And the prospective application of 2015 building codes would have a benefit cost ratio of 4-to-1, and some higher end codes specifically targeted might even have a benefit cost ratio as high as 11-to-1. So it's important to note that these aren't just for the sake of buildings, they're for the sake of occupants, all the users, all the people who depend on these buildings directly and indirectly, and that's sort of tenants, landlords, lenders, developers, and entire communities. And the hope is that these studies will motivate more private investment in mitigation, even though, we all know that business intent to survive in the face of threats gives quite a bit of motivation to invest in mitigation, but not necessarily to the socially optimal level. I'm an economist, if it's not clear by now. So we may often make a distinction between private benefits and private gains and gains for society, and those don't always match, especially when we have externalities or broad effects that the individual company can't reap on its own. It will not invest typically up to the point where it's doing everything it can for society as a whole, but will stop up to the point where it benefits itself. So there is that gap between what's privately optimal from the standpoint of individual company profits and benefits to society as a whole. So we might still have underinvestment in mitigation, even if we acknowledge that there's a lot of private motivation, maybe more so than in the public sector, to mitigate hazard threats. So the emphasis here is that resilience, as I've defined it more narrowly, saves too. So again, resilience often refers to any action that reduces hazard losses, but to me, there's a perfectly good word for doing that for things you do before the event, and that's mitigation. And I think the best use of the word resilience then is for all the various things we do after the event, but acknowledging that resilience is a process whereby we can build up resilience capacity beforehand through building up inventory, stockpiles, having emergency drills, identifying backup locations. But the point is these tactics are not implemented until the disaster strikes or the disruption strikes. Now, you can typically only prevent damage, property damage before the event. Maybe the one main exception is fire following earthquake. But for the most part, I get a lot of curious looks where I say reduce losses after the event. Well, how do you reduce property damage after the event? Well, typically can't. But property damage is not the only indicator of losses. And increasingly, and I think this is some success for economists, that we've seen reports talking about other economic indicators that are important, such as GDP and employment. And these are essentially measures of business interruption. So, yes, you cannot reduce property damage typically after the disaster strikes, but you can reduce business interruption. And business interruption is tricky because rather than one shot during the ground shaking and when the floodwaters are high or the wind speeds are high, it starts when the disaster strikes, but continues until you've recovered. And it is more complicated from a behavioral standpoint because that depends on the actions of individual businesses and public policy with regard to aid, how it's dispensed, what sectors are prioritized, what sectors might be subsidized or aided in various ways, clearing obstacles, etc. So let me talk a little bit about the prominence of business interruption. So about 12 years ago, I also had the honor of coordinating 8 studies to come up with a definitive estimate of the economic impacts of the World Trade Center attacks, and including one of my own. And we came up with a consensus estimate, and this is in 2007 dollars, so it's about double the numbers in today's dollars, that the property damage, the World Trade Center value was only about $25 billion, but the business interruption losses were 4 times that. Hurricane Katrina, the property damage in 2009 dollars, about $75 billion. The business interruption losses exceeded $100 billion. And one of the reasons they did was it took so long for New Orleans to recover, and some people say it really still hasn't. So the longer it takes to recover, the more business interruption that you have, and that's what we have to try to measure in this process. Some of you may be familiar with the shakeout earthquake simulations, major southern San Andreas Fault earthquake simulation. Well, the estimate there was in 2009 dollars to $100 billion of property damage, $66 billion worth of business interruption. So let me move now to define economic resilience a little more succinctly. And I've studied resilience in about a dozen disciplines: engineering, organizational behavior, planning, sociology, economics, ecology, where much of what we do today really got its start in the modern era. And so I found more commonalities than differences in terms of the essence of the definition. So what I've got here are generic definitions and then the economic definition in parentheses. So if we go back to Buzz Holling's work in the early 70s, that's most often cited in terms of what I refer to as static resilience, the ability to maintain function when shocked. And to an economist, we're talking about using the remaining resources as efficiently as possible. This gets to the heart of economics, which is the science of scarcity. And in the aftermath of a disaster, resources are even more scarce. So economics really gains some traction. So I'm going to focus primarily on static economic resilience. Dynamic economic resilience follows the work of Pym, and it mainly is referred to as hastening the speed of recovery. And to an economist, we're talking about investing wisely and expeditiously in repair and reconstruction. So investment to an economist is a time-dependent consideration, hence the term dynamic. Time-dependent meaning or being related to the fact that we are deferring future current consumption by investing, improving our productivity so as to be able to be more productive in the future by our investment today. And I've done some work that I can talk about later. So many definitions of dynamic economic resilience are about shortening the duration of recovery. It turns out that the more effective mechanism for reducing business interruption losses is accelerating the pace of recovery, not just reducing the duration. So a lot of this, if my definition still bothers you, it's synonymous with business continuity and a lot of what we talk about in terms of recovery. And I've come up with an operational metric about 15 years ago, which is very simple, but increasing number of people are just using. For instance, I noticed a paper by Cash Barker in the International Journal of Production Economics applying the metric to supply chains recently. And so we're talking about measuring resilience effectiveness. where we're measuring the benefits of these various actions. And if we combine this with the implementation costs, we have essentially the benefit cost ratio, similar to the 4-to-1, but, different numbers in this case. So let me give you an example of the metric. So remember I talked about the World Trade Center attack study? So there were 1,100 firms in the World Trade Center when the planes hit. 95% of them with 97% of the employment survived by relocating, mainly to Midtown Manhattan across the river to New Jersey. If all the firms in that trade center area would have gone out of business, the direct business interruption loss would have been $43 billion. If all the relocation would have been immediate, there would have been no business interruption losses. But it couldn't be immediate. It took businesses on average 2 to 4 months to relocate. And so they suffered $12 billion worth of losses. So here's my simple metric. You can see it's that bottom line. The avoided losses are the 43 minus 12 divided by the maximum potential, which is 43, a metric of 72%. 72% of the potential losses were avoided by this rapid relocation of businesses. Yeah, I take a question.
So, if all of the businesses did not survive, the secondary economy, like restaurants and others, are also affected by it.
Oh yes, but that's taken into account. In other words, yes, the study actually evaluated what we call the general equilibrium effects, which are fancy word for multiplier, what we often refer to as multiplier. So the multiplier is a little more than 2, but you get pretty much the same kind of result if you include the secondary effects. And I refer you to the paper. I've got at the end of the PowerPoint, I don't know if the PowerPoints are being posted, but at the end of the PowerPoint, there's a set of references, and that study is mentioned. And a lot of the work I do, especially something called the economic consequence analysis tool, is to measure the economy-wide effects, not just the direct effects. But I thought I'd make it a little more straightforward. But thanks for asking that. So again, simple metric, this can be applied to every resilience tactic, and that's the way we approach that, this analysis of resilience saves. As far as individual tactics, well, they're listed here. I think they're big enough to see. So we've identified about a dozen very popular tactics that are applicable. Conservation, most definitions are pretty straightforward. Maintaining production or service levels using lower amounts of an input, resource isolation, shielding part of the production process from having to be dependent on critical inputs. An example would be distributed generation. Inventories, using emergency stockpiles. One of the things that most people aren't familiar with is what we call production recapture or rescheduling. And this is making up lost production by working overtime or extra shifts after the power comes back on, if it's just a electricity disruption, or after you've repaired and reconstructed your facility. So another thing to point out right away, many of these tactics are very inexpensive. Conservation typically pays for itself or more than pays for itself. The cost of inventories is not the entire inventory, but just the carrying cost. Production recapture is just the cost of paying people overtime or extra shifts. Even import substitution, a lot of times you hook up connections with new suppliers and you find that they may even be cheaper than the traditional suppliers you've had in place for many years. So we've developed a theoretical model for a dozen tactics, a paper I first wrote in the Journal of Regional Science in 2005, analyzed 2 of these, conservation and input substitution. But the more recent one, just published last month in the International Journal of Production Economics, shows you the theoretical underpinnings for a dozen of these tactics. And we move then under funding from this Critical Infrastructure Resilience Institute, and we also had funding from NSF on dynamic economic resilience, which I'm not going to talk about. But we developed 2 survey instruments. One for Superstorm Sandy and another one for Hurricane Harvey. And the overall findings of the Sandy survey was that resilience really does pay, that the benefit-cost ratio was in fact 18-1, owing primarily to the very low-cost nature of implementing these resilience tactics. So we've also inserted these tactics into, and are parameterized are some various types of models, including computable general equilibrium and input-output models, to do case studies of port shutdowns, transportation disruptions, cyber attacks, using some of these estimates. And also the surveys are helping us in some lessons for measuring dynamic economic resilience. So some of the Sandy results, we administered this 5 years after the event. It would have probably been better to have done it 1 or 2 years after, but the majority of firms recovered in less than 2 years, and 2/3 of them reported property damage as well as ordinary business interruption. So it's interesting in our analysis to compare those that did and did not suffer property damage in terms of how resilience helped. But essentially what we've developed is a marginal cost curve for static economic resilience. And this is a step function, but, readily fit a curve through it. And these are average sort of cost effectiveness ratios, starting with some such as resource sharing, resource isolation, conservation, which are below the zero line, meaning they're cost saving to begin with in terms of the implementation, and they add on benefits. So the more negative or the better ones, on the positive side, the numbers go from 0 to potentially infinity with, in this case, it turns out inventories, for whatever reason, were the more expensive option. And I explain that a little more later on. These are the results for the Harvey survey, and what we see is the cost effectiveness is very high for negative number, meaning it's very high in this case in terms of overall savings. And then on the other hand, we also have resource pooling, which has a very high number on the positive side of more than 20-1. So if you average all these out, they become 18. We obtain the 18-1 number. What about another way to juxtapose mitigation versus resilience? So, as I said, resilience has cost advantages over mitigation, and I've explained the fact that there are more low-cost and cost-saving tactics. So much of the mitigation involves structural reinforcement. If we're talking about electric utilities, we're talking about having large transformers in waiting, or very expensive measures such as redundant systems, parallel systems, large investments. Here we're talking about, much smaller. And also, if this wasn't clear and I should have emphasized it, most of the resilience tactics, since we're talking about after the disaster strikes, are associated with the customers of the infrastructure providers, not the providers themselves. Okay? It's things they can do to deal without the critical input. And it's not just infrastructure, it's, manufacturing inputs, for instance, as well. So we've got that relative cost advantage. And the other very important thing is, usually when we talk about the benefits of mitigation, we have to do it in the probabilistic framework. We have to multiply those benefits by the probability that the disaster will occur. And often that's 1 in 10 chance, 1 in 100 chance. We have to multiply our big numbers we get at first by 0.1 or 0.01. Well, we don't have to do that and reduce the benefits on much of the resilience, especially that improvised and done after the fact. We do have to do it for what I call inherent resilience, is buying the emergency generator. But many resilience tactics You don't have to multiply them because they're only implemented under perfect certainty. In other words, you don't kick them in until the disaster is struck. So you know per perfect certainty it's happened, and so the multiplicative factor is 1.0, not some fraction. On the other hand, mitigation has some cost advantages over resilience. The options reduce risk for many customers, where in the case that we talked about resilience, it's each customer often acting on its own. Many mitigation options apply to several disasters and types. And it's important to remember that resilience only reduces business interruption. It typically is not going to prevent property damage or deaths. And even though I'm blowing the trumpet for resilience as I've defined it, I've typically said mitigation is still our best first line of defense, but resilience is a very worthy second line of defense. And overall, what we need to take more care of, and now that we've got these numbers that I've mentioned to you to measure the cost effectiveness, is strike the optimal balance between mitigation and resilience. And I would maintain that we're now leaning much more toward mitigation, because that's what we're used to. The hazards profession, in many ways dominated by engineers, tend to focus more on mitigation. But we need to do more comprehensive assessments of grand strategies, factoring in all the types of considerations I've talked about with respect to resilience. So just the last couple of slides. Noah Dormady and I, under the auspices of the Critical Infrastructure Resilience Institute, are developing something we call a business resilience calculator. So this is a decision support tool. It's part of I'm sure several of you are from DHS Centers of Excellence in Research and Education, big emphasis in DHS on what they call transition products. So this is a way we can transition our research on conceptual and empirical measurement of resilience into something of practical usefulness. So essentially this tool builds a resilience index for typical businesses, not just on the effectiveness of resilience, but on cost effectiveness. And we're able to address the issue of weights within the index, which most indices just finesse and say, oh, we've got 12 indicators of resilience or 20. We're going to compile these in index, and they're typically all given equal weight. Well, we've got a good way of dealing with and specifying the weights. Essentially, the results of our survey serve as a checklist of resilience tactics and kind of a default and presentation of best practice values until a business can do a self-assessment, and then firms can set targets for resilience. So I might say that this tool is mainly intended for middle-sized and small businesses. Big businesses are big enough to have their own emergency management, risk reduction officers and entire departments, and don't need this. But we have support from what we call the Center for the Study of the Middle Market, which is mid-sized businesses at Ohio State, and support from small businesses who can readily benefit from this tool. So essentially, it gives them a start. It gives them a checklist of what resilience tactics other firms have used, how successful they've been on average and in best practice, enables individual businesses, once they've started analyzing the situation themselves, to gauge where they stand and to chart a course for making some progress. And this is what the user interface looks like under development. So business information can be of two types, general and secure. There's a resilience score that it will spit out in terms of current resilience and targeted resilience that you can work toward. It will essentially compute the resilience tactics with respect to effects and costs for the various products that the firm is producing, and also help the firm in terms of improvement strategies for improving their resilience. All you have to do is hit the input data, either or both, hit go, and it will give you a series of sheets that will, for the first one, for instance, showing your score in juxtaposition to the sector average for each of the various resilience tactics for each of your product lines. So, in conclusion, there are many cost-effective economic resilience tactics. Customers have many inexpensive resilience options from which to choose, and we hope to make people more aware of these possibilities and, in the big picture of things, help better balance mitigation and resilience. What we've done in our recent studies is establish a primary data set over a wide variety of sectors and business types that individual firms and researchers hopefully can use. We've developing this practical tool of the Business Resilience Calculator, and we hope in the near future to work with on some policy implications and applications of this, helping government identify ways to support resilience and avoid duplicating and undercutting it. And ways government can do that, again, is we're removing some obstacles, the implementation of some of these things, allowing businesses to collaborate and coordinate more than they can, given some antitrust restrictions. Sometimes there may be a need for some abeyance of some immediate environmental regulations, and there are various other things in terms of reducing paperwork requirements, which can help speed this along. Finally, just let me mention I'm involved in NSF CRISP grant. I don't know if you have a term for, or the CRISPers or CRISPies, is there a term? But anyway, I'm one of you too, and I'm working with Andrew Liu and some others here at Purdue and other places. And finally, if this is posted, here a set of references. This latest paper is with one of my junior colleagues at USC, where we look at the balance between mitigation and resilience at the individual business level. I've got a paper under review with Ian Sue Wing, who's a first-rate CTE modeler, on looking at the macroeconomic trade-offs between the two, in a series of studies on down to the 9/11 study, an original study on in risk analysis on resilience and electric power systems, and the original Mitigation Saves 1 study summary and natural hazards review. So thank you for being a good audience. I'm happy to have been here today. Happy to answer questions.
So I have a question and sort of a long-winded comment question after that. The first is, have you done any assessment of if everybody applied what their tools are? And their tools are within the company, between companies, and heavily focused on what individual companies can do and government can do. What kind of change in the gap, the economic benefits, do you think would happen? How much of a big gap remains?
Yeah. Well, I have to say our tool has not been fully developed and put in practice. So, in terms of a value of information framework for assessing that, we believe that more information in terms of, our tool is intended to make people aware of options they might not have thought of entirely, to show them best practices from firms that have already implemented some resilience. And, and in an anticipatory manner, we expect it to be effective. As far as what we...
qualification, you just said it should get better, and then it's sort of they got just a scoochy bit better because most of them don't do anything.
Oh, no, most firms do. So our studies show that in the Harvey survey and the Sandy survey, we asked firms, well, which of the following resilience tactics did you implement? And also maybe there's some we didn't list, so let us know what you implemented. And 2/3 of the firms implemented at least one tactic on their own already. And then they told us what it costs to implement it, including some cost savings, ironically, or not surprisingly given our framework, and then told us how much business interruption was prevented by the application of that tactic. So we got hard numbers.
The tool then tells people this is how much it's going to cost. If you do this is how much it's probably going to cost. You know, these are the resources. So does it give them tools that gives them a resource?
Right. It gives them kind of a point of reference, but then the major part is their own self-assessment. So it gives them kind of a clue that this has been found to be very cost-effective in other firms. Why don't you consider it yourself? Doing a self-assessment as to what it would cost you and what benefits you think you would gain from it. So
the other comment is that by looking at within the companies and the sort of the intercompany stuff, I don't know if there's any framework for helping people organize these things, but by focusing on this is what I do within the company and this is what I do within the government, you're in a tragedy of the commons situation by definition, because those are the only two definitions that are two options of hard path. Ostrom's framework, on the other hand, says there are many more options out there.
Yeah.
And so what are you doing about implementing the full range of socio-ecological system, resilience?
Oh, sure. No, I'm very sympathetic to that, and so let me say that a lot of my analysis of modeling is economy-wide, and I'm very much associated with and done work relating to community resilience. So, and work with planners too. So I did that juxtaposition, but there are also emergency managers that will be interested in this and planners looking at the tool, and the whole is not just the sum of the parts, and we'll hopefully be looking at ways to develop synergies out of this as well, across businesses, between business and government, and so it can be used by them as well. And the tragedy, the commons issue is that, you know, some aspects of our society aren't necessarily owned by businesses, and even if government is the steward, they're abused, especially ecosystems, because nobody takes responsibility for them. And while I haven't thought of it, I would think there would be applications there. But thanks for bringing that up too.
For your talk, my question is on input-output versus the general equilibrium, and it seems that you have used both. So could you comment on the price elasticity? If there is a shock, how do we get the price elasticities, and how do we update those models?
Right. Well, I started my career doing input-output research, mainly on the economic impacts of pollution control. And after about 10 years of work in the field, I decided, well, I'd do an assessment of the literature on this. And I found that 11 out of the 12 studies that I evaluated, including my own, had an inherent bias using input-output, which is unidirectional. You have a shock positive, and the multipliers make it more positive. A shock negative makes it more negative, multiplies onto it. And I thought, well, what would the ideal system be? And I worked out this three-dimensional diagram where you'd include input substitution. Input-output, by the way, is essentially a model of all purchases and sales between sectors of an economy with a basis on the technological relationships of production. So it's very solidly grounded in the real world in terms of inputs into the production process. And essentially it models the economy as a set of interrelated supply chains. But the problem is that it's linear. It has no role for prices and markets. It has no behavioral content. And so I worked out this diagram where it allowed for input substitution, allowed for feedback effects, allowed for the role of prices. And then I thought, well, how can I do this with input-output? You could do any one of those in a manageable way. You couldn't do them all. And fortunately, 2 years later, somebody introduced me to this new approach called CGE modeling, computable general equilibrium modeling. So essentially, CGE modeling overcomes the I/O limitations. It's nonlinear. It has an explicit role for prices and markets. It has behavioral content. So you're not just replicating or optimizing. You can have various types of bounded rationality, which is important in the hazards field. So I still use I/O once in a while, and I/O is okay if you're talking about a short duration disaster, like an electricity shutdown or a port shutdown might last 2 days, 2 weeks, maybe 3 months. Because you don't have much opportunities for substitution. Prices aren't going to change dramatically. So I just published a paper on the shutdown of major ports in Port Arthur, Port Beaumont in Texas to oil supply, imports and exports, and I/O worked pretty well. I/O is very transparent, which is a positive. So most of my work involves CGE modeling. So the problem with CGE modeling, though, my first study, is we did a study of what would happen in Memphis if you reduced the electricity supply by 50%. So we got impacts that suggest the impact on the economy would only be a loss of GDP of about 4%. And we realized the standard CGE model is overly flexible. Just like the standard I/O model is overly rigid, standard CGE model is overly flexible. It has high elasticity of substitution. So what we've done is, in most of my studies, starting with the 2007 study on the electric power system, is reduced, well, actually even before, reduce the substitution elasticity to a very low level. Not zero, like implicitly in I/O, but 0.1. For critical inputs. And then the original 2005 paper showed how we could take data from a survey, Kathleen Tierney's survey, and recalibrate the substitution elasticities in a CG model to match the empirical work. So I refer you to that paper, which unfortunately is not, but you'd find it readily, how to calibrate the elasticities of substitution appropriately.
Thank you very much for your talk. It's always interesting to see what you're working on. My question, actually, you might have just sort of answered it. I'm not quite sure. In terms of looking at the resilience at the economy level versus at the firm level, have you looked at the scalability and the vertical integration there? So in terms of what impacts at the firm level can you then, and how do you use your approach to build up a better picture at the larger level?
So that's a good question, and one of the things that was only implicit in my definitions is both I/O and CGE essentially work with sectors of the economy, and CGE models do have an input-output database core, and some of them for many of the transactions between firms and input requirements are fixed coefficient or linear. The finesse in CGE modeling is that it's not just a sector, it's the representative firm that you're modeling. And so that is kind of the automatic translation of firm to sector. So one just essentially extrapolates that these average numbers you got for firms represent the sector, and then what the model does is mainly trace the interaction. But what you're getting at is becoming increasingly important in CG modeling, and that is looking at the distribution of firms, that firms are not all homogeneous, that size may matter. The number of firms in a market affecting its competitiveness is really a big deal these days. I haven't ventured into that area, but it's very worthy of pursuit.
Professor Rose, thank you for your presentation.
Sure.
Can you give some more insights on determining the discount rates for benefit cost analysis in such situations, especially social discount rate?
Right.
When the social rate of change and the duration is so different than the economic systems. World Bank has different opinion, USGS has different opinion.
Yeah. Well, I appreciate the question. We typically use somewhere between 3 and 5% and then do sensitivity tests. And Mitigation Saves, I think, uses 3%, does sensitivity tests of 1 and 7%. That's what we did originally, and I think that's what they're doing now. I'm an advisor on the Mitigation Saves too, rather than taking the lead role. I have to say, and I do a lot of work on climate change too, where discount rates are a big deal, and I've kind of stayed away from that. It's, to me, a little bit of a bottomless pit of controversy, and I wish I could say more other than tell an anecdote. Working with some people, I used to teach at Penn State. We were doing some work on synfuels operations, and some of the people in the group said, well, this is going to be a government operation, so we should have a 0 discount rate because the cost of borrowing to the federal government is 0. And an economist wouldn't go for that, because part of it relates to the opportunity cost and best alternative for the use of the money. And it's typically not 0. On the other hand, I don't know if you're asking about the conundrum of intergenerational discounting at all. No, okay, all right, that's a whole another story. So I can't help you very much. I'm sorry to say, other than it is an important issue, but typically you'll see you will see sensitivity tests. They change the numbers a little, the numbers might go down with a very high discount rate to 2.5 to 1, or it might go up to 5 to 1, but they're still positive. Mitigation still saves. And the same thing with resilience. And the thing about resilience is less subject to the discount rate because we're talking about shorter term actions. So I guess I can say that. It's another advantage. Is you don't have to worry about long-term discounting for a lot of things. So thanks for spurring that thought.
So Professor Rose, I have a question. Thank you very much for your talk. I'm wondering if you can elaborate a little bit on the resilience index, and in the business resilience calculator, what are the components that are included? Are you including any infrastructure-related variables like transportation accessibility, market access, labor access? Can you elaborate on that?
Okay. Well, let me say, and maybe I should have made this more explicit, but the index in the resilience calculator is just composed of each of the resilience tactics that I mentioned. So about a dozen of those. And the weights are dependent on the relative ability to reduce losses. So if inventories can only reduce 5% of the losses, but production recapture 20%, then production recapture has 4 times the weight. So the weights are the relative proportion of total losses avoided that each tactic brings about. So it's pretty simple in that way. Now, there are some things to consider. So I think one of the papers I listed is on transportation resilience and post and transport policy in about 2011. And I make the case there that one of the things you want to consider is that if you're talking about the recovery of a transportation system, it does not require that you return to the same number of original trips. So we applied this to the London subway bombings. And that you need to take into account that there are alternatives that make you resilient without falling in that trap. And the classic examples are walking and telecommuting. So, that goes a little beyond the normal transportation of, alternative modes or repairing and reconstructing the established subways. Okay, thank you, everybody.